All right. So in the first one, children, in the figure, we see an equilateral triangle PQR, right? Equilateral triangle PQR meaning PQ is equal to QR is equal to PR. And we also have a square QRST. The quadrilateral below QRST is a square. And again, the square, all the sides are equal. Now, there is one side which is common to the equilateral triangle and the square. There is one side which is common to the equilateral triangle and the square. And that is QR. QR is a side which is common. Okay. This side is common to both the equilateral triangle and the square. Now let's just take some numbers to understand better. Now I'll say the side of the equilateral triangle is say 5 centimeters. So it'll be 5, 5 and 5. Now if QR is 5, that means QR is the side of the equilateral triangle as well as the side of the square, right? So if QR is 5 centimeters, automatically all the other sides of the square also measure 5 centimeters, right? That means you see that all the line segments PQ, QR, PR, QT, TS, RS, all the sides of the triangle and the square are equal. Why? Because there is one side which is common to the triangle and the square. So the sides of the triangle and the sides of the square have the same measure. Whatever measure, same measure. See, I repeat that. Now, supposing, okay, let's take for the square. Supposing the side of the square is 10 centimeters. Now, in a square, all the sides are equal. So it will be 10 centimeters here, 10 centimeters here, and 10 centimeters here, because all the sides of the square are equal. Square, all sides are equal. Now, we see that QR is 10 centimeters. And what is QR? It is also the side of the equilateral triangle, which means PQ is also 10 centimeters and PR is also 10 centimeters. So all these line segments are equal. Okay, all right. Now we need to show that given this information, we need to show that PT is equal to PS. So to show that two sides are equal, okay. Now PT is a side of which triangle? PT is a side of which triangle? It's a side of the triangle PQT. PT is a side of the triangle PQT. And PS is a side of the triangle PRS. When you need to show that two line segments are equal, mostly, okay, I'm saying in most cases. So here PT is equal to PS, right? So PT will be a side of one triangle and PS will be the side of another triangle. So to show that PT is equal to PS, we need to show that these two triangles are congruent to each other. That means these two triangles are identical triangles. And so their corresponding sides, PT and PS, are equal. We can't write this like this. You have to prove all this. I repeat, we need to show that PT is equal to PS. PT is a side of the triangle PQT. And PS is the side of the triangle PRS. That is this triangle and this triangle, these two triangles, right? We have to show that these two triangles are congruent to each other. They're congruent meaning they're identical. So once you show that they're congruent using CPCT, corresponding parts of congruent triangles are also congruent. Niveda? Are also congruent, right? Therefore, PT is equal to PS. So we have an understanding of the proof. So we know that the proof goes like this. So now we'll have to prove that the two triangles are congruent to each other. All right. So for that, you need to use one of the 5 congruence rules. And RHS They don't look like right triangles. They're not right triangles, so you cannot use RHS. You can think of the other four congruence criteria. All right. Now, since this one is an equilateral triangle, this angle is 60 degrees. And below this is square. What is that? RQTS is a square, or QRST is a square. So this one is 90 degrees, right? So this angle of the triangle, because we are taking this triangle, right? This triangle. So this angle of the triangle is equal to 60 plus 90, 150 degrees. We're able to find the measure of one angle. See, I'm talking about this full angle. Why we're taking this full angle? This is an angle of the triangle PQT. Now, when you take triangle PQT, don't see this line which is coming in the middle. Don't see this line. Don't see this line in PRS. Don't see this line in the middle. See only the triangle PQT with the sides PQ, QT, and PT. Don't see any line segment going between them. See the triangle empty in the middle. You understand that? So now we are talking about this angle, angle Q. It's very relevant. We are not simply finding Q because we can find it. We are finding Q because it's a relevant angle. It's an angle of triangle PQT. It will help us in proving the triangle is congruent. Similarly, find angle R. Angle R. Okay. Now this one is 60 degrees and below is 90. This is 60 and this is 90. So this full angle is equal to 60 plus 90, 150 degrees. The same on the other side. 60 plus 90, this full angle is 150 degrees. 150 degrees. Now, in triangle PQT and PRS. Understand, children? This triangle. We're talking about this triangle and this triangle in these two triangles. Correct? In these two triangles. Okay. PQ of this triangle is equal to PR of this triangle. PQ of the first triangle is equal to PR of the second triangle. Why? Because PQ and PR are the sides of the equilateral triangle and they're equal. Next, QT of the first triangle. When I say first triangle, you understand, right? QT. Okay, 1 minute. Before that, let me ask you, which are the sides of the triangle PQT and PRS? Which are the sides? Tell me the sides of PQT. Yeah. PQ, QT, and PT. Too simple, no question for you, so you're not answering. And the sides of PRS, PR, RS, and PS. So you can talk about these sides. These three sides of the first triangle and these three sides of the second triangle. No other line segment you can use. Nothing else is relevant. If you want to say that a side of the first triangle is equal to a side of the second triangle, you should say one of these. Correct? Of the first triangle is equal to one of the sides of the second triangle. Simply writing some line segment is equal to some line segment is not relevant. Okay. So PQ of the first triangle is equal to PR of the second triangle because they are the sides of the equilateral triangle PQR. And then QT of the first triangle is equal to, what is this? RS of the second triangle because they're the sides of the square and they're equal. Okay. And then this angle is 150 degrees. So this angle of the first triangle is equal to this angle of the second triangle because 150, 150. Now you can see that for this angle, QP and QT are the arms of the angle. And for this angle, RP and RS are the arms of the angles, right? So which means it is two sides and the included angle. Two sides and included angle. See here, these two sides contain this angle and these two sides contain this angle. For this angle, these are the two arms. And for this angle, these are the two arms, which means the rule is SAS. Two sides and the included angle. When can you use this? When these two sides are the arms of the included angle. So by SAS congruence criterion, the two triangles are congruent to each other. Only these three parts of the first triangle equal to these three, the corresponding three parts of the other triangle. But this is enough to show that they are congruent using the SAS rule, right? Now what follows? Now you should write the order correctly. All this I've told you in the first class of that is on Sunday. I'm not repeating that, so you know how to write the order. So now that the two triangles are congruent, by SAS rule, write the order correctly. You can see here. PQT is congruent. I'll share that recording, so go through that recording. If you want to recall how to, name the triangles in the correct order, go through the recording. So PQT is congruent to PRS, SAS rule. Now you can see here, PT is equal to PS. See the positions, PT, PS. So PT is equal to PS. That's what we had to prove. PT is equal to PS, CPCT. Now that we have proved the triangles are congruent, those things which we did not know are also equal. So PT of the first triangle corresponds to PS of the second triangle. How? From this order we can make out. We can make out from this order. PT is equal to PS. So PT is equal to PS, CPCT. Corresponding parts of congruent triangles. All right. That's over. That's one thing. That's over. Now you need to also find angle PSR. You need to show that it's 15 degrees. Angle PSR. Okay, PSR. Where is it? PSR, PSR, this angle. You need to show that this angle is 15 degrees, 1-5. All right. Okay. So now we know that this side is equal to this side. We just understood, no? When we started, we understood that the three sides of the equilateral triangle and the sides of the square, they're all equal. Why? Because there is one side which is common to the triangle and the square. So that makes all the sides equal, right? So now you will be like, how do you write that? Okay, you're saying we understand, but how do I show it? How do I present it? This is how you need to present it. Which is that common side QR. All right. So QR. Don't see the working here, children. Look at this one. QR is at common side, right? Write the 2 times QR. QR is equal to that side which is common to the triangle and the square, right? That QR. QR is equal to. Now, can I write QR is equal to PR from the triangle and QR is equal to RS from the square? QR is equal to PR from the triangle and QR is equal to RS from the square, correct? I've taken the common side. The common side is QR. The common side to the triangle and the square is QR. Now, with respect to the triangle, QR is equal to PR. And from the square, QR is equal to RS. So QR is equal to PR. QR is equal to RS. That means PR is equal to RS. That means PR is equal to RS. Because QR is equal to PR and QR is equal to RS also. So that means PR is equal to RS. PR is equal to RS. So PR is equal to RS. That's what we've written here. PR is equal to RS. So you can see here QR, whatever I've mentioned here, QR is equal to PR in triangle PQR. I've called it A. And QR is equal to RS. QR is equal to RS from the square QRST. I've called it B. So from A and B, from A and B, from A and B, from A and B, PR is equal to RS. PR is equal to RS. In which triangle? PR is equal to RS in triangle PRS. In triangle PRS. PR is equal to RS in triangle PRS. No, PR is equal to RS. These two sides are of which triangle? PRS. Now take up the triangle PRS. Now take up the triangle PRS. In this triangle, when two sides are equal, isosceles triangle property. In a triangle, when two sides are equal, the angles opposite to them are also equal. In a triangle, when two sides are equal, the angles opposite to them are also equal. So in this triangle, PRS, PR is equal to RS. See, don't see this line segment in the middle, this one, don't see this. PRS, this side is equal to this side. How do we know that? See, we got it here, PR is equal to RS. So which is the angle opposite to this side? This angle. The angle opposite to this side is this angle. These two angles are equal. See here, in a triangle, when two sides are equal, the angles opposite to them are equal. Opposite to this side is this angle. Opposite to this side is this angle. If this side is equal to this side, this angle is equal to this angle. So this side is equal to this side. Okay. Opposite to this side is this angle. Inside the triangle, you should see. You should not say, ma'am, I'm able to see this angle opposite to this side. See, within the triangle, inside the triangle, you can see so many things opposite to one line segment. But you should see in that triangle, we are talking about a triangle. In a triangle, when two sides are equal, the angles opposite them are equal inside the triangle. So which are the three angles of the triangle? Which are the three angles of the triangle? This is one angle. This is one angle. This is one angle. Now, if this side is equal to this side, the angle opposite to this side is this angle in the triangle. And the angle opposite to this side is this angle in the triangle. In other words, this side and this side, which are equal, they contain this angle. No, leave that angle. The remaining two angles will be equal. Leave that angle. Those two equal sides, they contain an angle. Leave that angle. The remaining two angles are equal by the isosceles triangle property. So this angle is equal to this angle. Now you tell me, you know that this angle is 150 degrees. We know the angle sum property. In a triangle, the sum of the three angles is 180 degrees. And one angle you know is 150. So remaining sum is 180 minus 150, 30 degrees. This is the remaining sum. That remaining sum has to be divided between two angles. But they are saying they're equal. We both are equal. So 30 will become 15, 15, right? So that's how PSR, this angle, PSR is equal to 50. This is 15 degrees. And this is 15 because these two angles are equal. So each angle is equal to 15 degrees. That's what you see here. That's what you see here. And for your convenience, see now, children, when you start this proof, when you start the proof, you cannot immediately mark all the angles 1, 3. You cannot mark it like that. You please draw the figure in your book, meaning your notebook, your exam paper. Mark the angles as and when needed. As soon as you start, how will you know that you should mark 1, 2, 3, 4? You should mark how many angles here? 6 angles. How do we know that we should mark all these 6 angles? Nobody knows. So you should mark when needed. Because you don't want to name it PQR, PRS. It's tedious not to name it like that. So it's easy to use numbers for angles. It's easy. See, when you call this angle 1, it's easy to understand. When I say angle 1, all of you know it's this angle. But when I say PQR, PRQ, you need to really see where it is PQR. Yeah, okay, it's there. But when I say angle 1, you can immediately see angle 1 there, right? So please use numbers for angles in your answer also. It becomes easy to check your answer also, your proof. It's also easy to check your proof. If you want to visit your proof and see if you've written it correctly, it becomes easy when you use numbers for angles. Otherwise, it's difficult to check. Every time if you write PQR, PRQ, QRP, PTQ and all that, it's so difficult. So now, I'm answering the question, how do I know that I need to mark angles like this? So that's what I'm saying. As in when you need to go to the figure and mark it. You cannot mark all these angles as soon as you start the proof. You cannot draw this figure and mark all these angles. So now see, we wanted to say that angle 1 and 2, 60 degrees. So you go there and mark angle 1, angle 2, 60 degrees. Then you want to say that 3 and 4, 90 degrees. So 3 is equal to 4, 90 degrees. This is how you present the answer. So I'm adding the two. Angle 1 plus angle 3 is equal to angle 2 plus angle 4 is equal to 60 plus 50. 60 plus 90, 150. How to present the answer? Angle 1 is equal to angle 2, correct? 60 degrees. Then angle 3 is equal to angle 4. How much? 90 degrees, correct? I'm adding these two results. So angle 1 plus angle 3 is equal to angle 2 plus angle 4 is equal to 60 plus 90 plus 150. So now what is angle 1 plus angle 3? 1 plus 3 is PQT. PQT. And what is 2 plus 4? It's PRS. PRS is equal to 150. All right. All right. So see, I've mentioned the two triangles. You can see the two triangles PQT and PRS. I've mentioned this triangle and this triangle. In these two triangles, this side is equal to this side is what I've written here. And then this angle is equal to this angle is equal to 150. You can see here. And then QT is equal to RS. QT is equal to RS. So the two triangles are congruent by SAS rule. Then CPCT, you get this one. And then you must show that these two sides are equal because you'll have to find PSR, this angle. So show that these two sides are equal. So we've shown that here. So if these two sides are equal, these two angles are equal. And then angle sum property. Yeah, I'll just give you 3 more minutes. Go through the proof. I'll wait for 3 minutes, children. Please go through the proof, and if you have any questions, you can ask me.
Ma'am,
Yes.
can you please explain after that PT is equal to PSCPCT?
After which one? After this one, PT is equal to PS. This one?
Yes, ma'am. Yes, ma'am.
Okay, yeah. 1 second. I'll take the figure on next, meaning on a different slide and tell you. Yeah. Yeah. Please help me get started, or I'll just write the first one, then you continue. So QR is equal to PR, correct? QR is the side which is common to the triangle and the square. QR. So I'm writing QR is equal to PR. That is, the common side is equal to one side of the triangle. Now you complete the next one. QR is equal to
RS, ma'am.
RS. QR is equal to RS. So QR is equal to PR and QR is equal to RS. That means PR is equal to RS. That means PR is equal to RS. This implies PR is equal to RS. Now take up the triangle. Okay, take up the triangle. This triangle. Okay, PRS. Okay. Now we have to show that this angle is 15 degrees. This one is 15. So what is the result we have? PR is equal to RS. PR is equal to RS. These two sides are equal. So in triangle PRS, in this triangle PRS, we have proved that we are not simply writing PR is equal to RS. We are not simply writing PR is equal to RS. We have justified, we have proved it. PR is equal to RS, we have proved. So in a triangle, when two sides are equal, the angles opposite to them are also equal. Isosceles triangle property. So I said, in this triangle, this side and this side, these are the two equal sides. They contain this angle. No, you leave that angle. The remaining two angles are equal. By this property, the remaining two angles, the two equal sides contain one angle. The two equal sides are the arms of one angle. See this angle. These two sides are the arms of this angle. Leave that angle. Leave this one. The remaining two angles are equal because this angle is opposite of this side and this angle is opposite of this side. So since these two sides are equal, by the isosceles triangle property, this angle is equal to this angle. These two angles are equal. Now I have numbered it 5, 6. Okay. So I've numbered which one 5? 5. This one is 5. This one is 5 and this one is 6. All right. So I write like this. Angle 5 plus angle 6 plus angle PRS is equal to 180. Angle some property. Angle 5 plus angle P. Okay. Angle 5 plus angle 6 plus angle PRS is 180. Correct. But we have to find this angle. This angle PSR. See here. We have to prove that PSR is 15 degrees. You can see it here. See here. PSR is 15. We'll have to show that PSR is 15. Okay, so now we know that angle 5 and angle 6, they're equal, right? Because these two sides are equal. Therefore, angle 5 is equal to angle 6. Isosceles triangle property. Isosceles triangle property. The two sides are equal. So the angles opposite to them are equal, which means angle 5 is equal to angle 6, correct? Yeah, now use the angle sum property. Angle 5 plus angle 6 plus PRS is equal to 180. Now you can replace 5 with 6. You can replace angle 5 with angle 6. Why? Why should you replace? Because we have to find 6 only. Okay, so 5 and 6 are equal. So let me write 5 as 6. Not just like that. 5 and 6 are equal angles. And we are writing 6 because we need to find PSR, angle PSR, which is angle 6. So angle 6 plus angle 6 plus angle PRS is equal to 180. Okay, we know this is 150, right? Let's substitute that. This is 150. We know that this is 150. Plus 150 degrees is equal to 180. So 2 times angle 6. Angle 6 plus angle 6 is not angle 12. When I explain this, I'm not treating all of you as a dumb. I'm sure you all know twice angle 6, but I'm just in case you suddenly felt so, I want you to remove that from your mind. Angle 6 plus angle 6 is not angle 12. It's twice of angle 6. Don't add the numbers. So angle 6 plus angle 6 is twice of angle 6 is equal to 180 minus 150. So twice of angle 6 is equal to 30 degrees. So angle 6 is equal to 30 by 2, which is 15 degrees. Hence, we have proved that angle PSR, angle 6 is this one, angle PSR is equal to 15 degrees. Yeah, so thank you for asking that question. Who was that?
Ma'am, Bhavishya.
Bhavishya. Very good, Bhavishya. Your doubt. Now, all of them have understood, I think, more clearly. Thank you, Bhavishya. Yeah, anything else, children? Yes, Krishna Priyan. Anything else, children? None? Okay. So I'll just repeat this. When you have to prove that two sides are equal, when you'll have to prove that two sides are equal like this, just see if this one is a side of a triangle and this one is a side of a triangle. And yes, in this case, PT is a side of this triangle and PS is a side of this triangle. So immediately you should, like prepare your mind that, okay, the proof should somewhat go like this. We need to prove that these two triangles are congruent to each other. Once you prove that these two triangles are congruent, by CPCT, you can get that result PT is equal to PS. All right. Okay. And this one is unique. This is different. I can't say now for this one, you have to remember like this. This one is unique like this. You can get different questions. But in general, when you'll have to prove that two sides are equal or two angles are equal, it can come through congruency. Okay. So here in this figure, we have a right triangle ABC. Can you see the right triangle? Here is a right triangle. Let me take an empty slide. 1 minute. So we have a right triangle. I'll name it later. There is a square. This is the right triangle. Okay. There is a square drawn on the hypotenuse, that is described on the hypotenuse. There is a square described on the hypotenuse. So this is the hypotenuse. There's a square described on the hypotenuse. Okay, there's a square also described on one of its legs. One of its legs. All right, let me see the question. So in the given figure, ABC is a right triangle angled at B. So ABC is a right triangle angled at B. If BCDE is a square on the side BCDE is a square on the side BC, and ACFG is a square on AC on the hypotenuse AC. ACFG is a square. Both are squares, but these two squares will not have the same length. Because we know that in a right triangle, the hypotenuse is the longest side. It's the longest side. So the side or the sides of the square described on the hypotenuse will be longer than the sides of the square described on BC. Because BC is shorter than the hypotenuse AC. So obviously all the sides of the square will be less than the sides of the square. Okay. Now we need to prove that AD is equal to FB. AD, where is AD? So we'll have to join AD. And then FB. Okay, these two triangles. We need to show that. Okay, we need to show that AD is equal to FB and AD is in triangle ACD. AD is in triangle ACD and FB is in triangle BCF. So which means we'll have to show that these two triangles are congruent to each other. Once you show that they are congruent, CPCT, we can get the result. We'll have to show that AD, so AD was not connected. So you'll have to connect AD is equal to BF. BF also was not connected. So you'll have to join BF. Now AD is in triangle ACD and FB or BF is in triangle BCF. Right, so show that these two triangles are congruent. CPCT, you can get this result. AD is equal to FB. You need to prove that. I'll write TPT here to prove that. Okay. AD is equal to FB. AD is equal to FB. All right. So now look at this. Look at this triangle ACD. Look at this triangle ACD. I'll just use the same color, children. 1 second. We use this. Now, this is the square, right? ACFG is a square, right? So these two sides are equal. I'm using the same color. If the sides are equal, I'm using the same color. College children. So I've used the same color if the sides are equal. All right. Now I have marked, I have, like darkened two sides with red, right? Because AC and CF are the sides of the square ACFG, the square which is described on the hypotenuse. The square ACFG is described on the hypotenuse. So AC will be equal to CF, right? The side of the square. And then there's another square below, right? Which is described on the leg BC, BCDE, BCDE. So BC is equal to CD, right? Because all the sides of that square are equal. Correct? Yeah. Now, we'll have to show that these two triangles are congruent, ACD and BCF, that I told you earlier, why we are taking these two triangles. Now, AC of triangle ACD is equal to CF of triangle BCF. See them? AC, this one, this AC, this red AC is, okay, 1 minute. Which are the sides of triangle ACD, children? ACD, which are the sides? AC, CD, AD. Which are the sides of BCF? BCF, BC, CF, BL. All right. Now we have written what? AC is equal to CF. This AC is equal to CF. AC of this triangle is equal to CF of this triangle. What am I showing? I'm not, now don't ask me, ma'am, that's a second side. You should, not second side, first side. I'm saying that AC is the side of this triangle and CF is the side of this triangle. That's what I'm trying to say. Now don't say that's down, this is up. These are the sides of this triangle. These are the sides of this triangle. And see what we are writing. AC of the triangle ACD is equal to a side of the other triangle, CF of the triangle BCF. I'm trying to say that we are writing a side of the first triangle is equal to a side of the second triangle. If you write, simply if you write two sides are equal, that's not a valid equality. Those two sides may be equal, but you cannot write any two sides. You need to write, you have considered two triangles, right? You have taken two triangles. Now, each of the triangles will have only three sides. First triangle, three sides, second triangle, three sides. So you must say one side of the first triangle is equal to any side of the second triangle. Side of one triangle should be equal to the side of the other triangle. Simply writing some line segment is equal to some line segment is not a valid, like information to show that they are congruent. So I'm saying AC of the first triangle is equal to CF of the second triangle. In the same way, write it here. In the same way, CD of this triangle, see CD of this triangle, the first triangle, CD of the first triangle is equal to BC of the second triangle. See, CD is equal to BC. CD of the first triangle is equal to BC of the second triangle. Blue, they're equal. If you write BC is equal to CD, that's not that's true, but that's not an information. If you write BC, oh, sorry, not that, sorry. Sorry, I was about to say this one by mistake. If you simply say, okay, this is a square, this is a square. So B is equal to ED. B is equal to ED, correct. But that's not useful here. This information is not useful here. BE is equal to ED, correct? But that's not useful here. Simply writing 3 equalities is not sufficient. Okay, I hope I'm reaching all of you. So like this. Then now look at AC and CD. AC and CD. This is the included angle. This is the included angle. Which is the included angle? ACD. ACD is the included angle. Yes or no? ACD. Again, what included angle? I spoke about this in the first class, children. Included angle. I told you if it is an included angle, the two sides must be the arms of that angle. Now, in this proof, in the first triangle, we have mentioned about AC and CD. We have mentioned about AC and CD. So this is the included angle ACD. In the second triangle, we have mentioned about CF and BC. CF and BC in the second triangle. In the second triangle, we mentioned about CF and BC. CF and BC. So this is the included angle. BCF is the included angle. BCF is the included angle. Now they are not equal. It's not given. You'll have to show that they are equal. I have written it. But that's not given, no? You'll have to show that they are equal. We'll show. I'll tell you how you can show that they are equal. Okay. So this is one triangle, this is one triangle. Now I have written ACD. Okay, I've written ACD is equal to BCF, but we need to prove that. ACD is the angle contained by these two sides, and BCF is the angle contained by these two sides. Okay, now how do we show that they're equal? Is this 90? Is this 90? Is this 90? Okay. So let me mark this angle 1 and this angle 2. Or you can mark this one and this 2, anything. Now, is angle 1 equal to angle 2? It was 90, 90. Can you see this one in the middle? This one? I'll call it 3. Now we'll add angle 3 to both the sides. We'll add angle 3 to both the sides. You can do anything. See, when you have an equality, no, you can change it. You can change it, meaning you can do anything, but do the same thing to both the sides. In an equality, we have LHS and RHS. Whatever you do to the LHS, do the same thing to the RHS. So I have angle 1 is equal to angle 2. I'm adding 3 to the left hand side, angle 3 to the left hand side. Do the same thing to the RHS. So now what is angle 1 plus angle 3? What is angle 1 plus angle 3? ACD, angle ACD. Yes or no? And what is angle 2 plus 3? 2 plus 3 is BCF. Is it BC? That's how you should prove that these two are equal. You must write that. You can see it here. You can see it here. I've numbered angle 1, angle 2, and angle 3. You can see an angle 1 is equal to angle 2, 90 degrees. Then we're adding angle 3 to both the sides. Angle 1 plus 3 is equal to angle 2 plus 3. So now what is 1 plus 3? Angle 1 plus angle 3, this angle, ACD. And what is 2 plus 3? 2 plus 3, this 2 plus this one, 2 plus 3, BCF, BC. So ACD is equal to BCF. And they are the included angles. These two sides, the side AC and the side CD, CL, AC and CD. These two sides contain this angle ACD. And in the other triangle, the sides CF and BC, CF and BC. They see between these two sides, you have this angle 2 plus 3. BCF. So this makes SAS rule. This is side, this is angle, this is side. All right, side angle side. Two sides included angle. Two sides included angle. So the two triangles are congruent by the SAS congruence rule. See, order, you should name the triangles in the correct way. So AD is equal to FB, CPCT. AD is equal to FB, CPCT. So to prove that AD is equal to FB, you should just take the two triangles, show that they are congruent. Once they are congruent, CPCT, they are equal. Yeah. I'll wait for some time. Please go through. I'm coming. Yeah. All right. Have we finished writing this one, children? Finish writing.
Yes, ma'am.
Okay. Please go ahead. I'll just continue. Write down this one.
I just go maybe with BC, the best is You only said this is not a topic. That's what you see. I don't know how to see. Post lunch, yes. Oh, yes.
Done writing? Yeah. All right, we'll see the third one. Okay. So ABCD is a quadrilateral in which AB is parallel to DC. AB is parallel to DC. And P is the midpoint of BC. P is the midpoint of BC. So that means BP is equal to PC. Now, sometimes we get confused or we make this mistake. P is the midpoint of BC, no? So BP is equal to PC, not AP is equal to PQ. If you have to take AP is equal to PQ, then it should be given that P is the midpoint of AQ. If it's given that P is the midpoint of AQ, then AP is equal to PQ. But what is given in the question? It is given that P is the midpoint of BC. That means BP is equal to PC and that's it. So P is the midpoint of BC on producing AP and DC. On producing AP and DC, meet at Q. Prove that AB is equal to CQ. AB is equal to CQ. So our usual feeling, that AB is the side of one triangle, AB is the side of this triangle, then CQ is the side of this triangle. So mostly we'll have to show that these two triangles are congruent and we'll get this result AB is equal to CQ. Okay. So tell me, in triangle ABP, where we have AB, and CPQ, in triangle CPQ, where we have CQ, correct? Yeah. Prenu, tell me the first one. See, when we have parallel lines, we can find alternate angles and say that they're equal, corresponding angles are equal. All right? Yeah. AP is equal to PQ. AB is equal to Kanna, அதுதான் prove பண்ணணும் equal ன்னு. AB is equal to CQ. That only we have to prove. BP is equal to PC. BP of. So see, these are the sides of one triangle. These are the sides of one triangle. And these are the sides of the other triangle. These are the sides of the other triangle. Okay. So we know that BP is equal to PC. Why? Because P is the midpoint of BC. So BP is equal to PC. So BP of the first triangle, you can see BP is the side of the red triangle and CP is the side of the blue triangle. Okay, you can see red sides and blue sides. Red sides of one triangle, blue sides other triangle. So you can see that BP of the red triangle is equal to CP of the blue triangle. Correct? BP is equal to CP. Why? Because P is the midpoint of, you should write the reason, because P is the midpoint of BC. That's a reason. Yeah, you have a doubt? Angle A is equal to angle Q. What's the reason? Alternate angles are equal. Okay, you're saying this angle, you're saying this angle is equal to this angle. Yeah, correct. Angle 1 is equal to angle 2 because alternate interior angles are equal. See here, parallel line, transversal, parallel line. Here is angle 1, here is angle 2. These two lines are parallel is given and this is the transversal. So AB, this is AB, this is AB, this is D and Q. You can see that. These two lines are this one is parallel to this one and this is the transversal. Alternate angles are equal. Angle 1 is equal to angle 2. You can also write. You can also mark this angle. You can also mark this one 3 and 4. And see here, parallel line, transversal, parallel line. This angle and this angle because these two are parallel. These two also are equal. Alternate angles are equal. Angle 3 is equal to angle 4. See here, these are opposite sides are parallel. The opposite sides are parallel. This full thing, opposite side, these two opposite sides are parallel. So parallel line, transversal, parallel line. This angle is equal to this angle, alternate angles. You can also say angle 1 is equal to angle 2, alternate angles, anything you can write. So I have mentioned, I don't know what, 1 and 2. Okay, so here, so again, in the first class, I told you that sometimes you will have more than sufficient information. Then you can write anything. You should write only 3. And those 3 should satisfy a congruence rule. When you have more information, you cannot write any 3. You must write those 3 which can satisfy a specific congruence rule. Okay. So I'll just explain what I've written in the next slide. Okay. So I have mentioned about the vertically opposite angles. In fact, here so many, all the three pairs of angles equal we can show. So angle 5 is equal to angle 6. From this marking, don't compare what you've written and what the numbers are put here. They might differ. The numbers in your book and the numbers here might differ. So angle 5 of the first of the red triangle is equal to angle 6 of the blue triangle. Vertically opposite angles are equal. BP of the red triangle is equal to CP of the blue triangle because P is the midpoint of BC. Then angle 3 of the red triangle is equal to angle 4 of the blue triangle. Alternate interior angles are equal. So now this makes ASA 2 angles and the included side. 2 angles and the included side. Because you have mentioned about BP and CP. See, this is BP. This is BP. This one is BP. All right. BP, you can see there contains angle 3 and angle 5. Angle 3 is here, angle 5 is here. BP contains angle 3 and angle 5. And CP, you can see a CP, it contains angle 6 and 4. 6 and 4. One side and the two angles in the included side. 2 angles in the included side. So by ASA, 2 angles included side. ASA congruence rule, the 2 triangles are congruent to each other. There is one side, and for both the angles, that is an arm. Included side means 2 angles in the included side means that one side is a common arm for both the angles. One angle will have 2 arms, right? So included side means that side will be a common arm to both the angles. Now look at angle 3. To erase everything because it's too crowded. Very crowded. 1 second. Now, which are the arms of angle? I had marked 3 here. Did I mark 3 here? No. I think I marked 3 here and 4 here. 5 here and 6 here. Okay, whatever. Okay, I marked 1 here and 2 here. Okay. Now, children, when we say, when you say angle, okay, which are the arms of angle 5? AB and BP. AB and BP. Which are the arms of angle 3? Of angle 3? PA and PB. It's difficult when I write, 1 second. It's very difficult. See, you can just. Angle 5, this is one arm, this is one arm. Angle 3, this is one arm. See, the same thing, this is one arm. When we say 2 angles and included side, that included side, 2 angles are there, right? So each of the angles will have 2 arms. That included side will be a common arm for both the angles. And the two angles for your common arm. That's the included side. In the other triangle also, you have mentioned about angle 6 and angle 4. You have mentioned about angle 6 and angle 4. Which are the arms of angle 6? This is one arm, this is the other arm. Which are the arms of angle 4? This one only. See, this one and this one. So this one is the common arm. That's the included side. For angle 4 and angle 6, this is the included side. So by ASA congruence rule, the 2 triangles are congruent to each other. Now, angle 1 is equal to angle 2, alternate angles are equal. Angle 3 is equal to angle 4, alternate angles are equal. Angle 5 is equal to angle 6, vertically opposite angles are equal. Vertically opposite angles are equal. And then we know that this side is equal to this side. Now, you can use ASA or AAS here. You can use AAS or ASA rule. There is no A is not a valid congruence rule. You cannot write angle 1 is equal to 2, angle 3 is equal to angle 4, angle 5 is equal to angle 6. So they are congruent. AAA is not a valid congruence criterion. So you cannot write all the 3 pairs of equal angles. So since you have more information, you can use 2 pairs of equal angles and 1 pair of equal sides. AAS, ASA. If you want to use AAS, you can mention any 2 angles and you can mention 2 angles and some other side. It should not be the included side. So for this, if you want to use this rule, then you must use angle 1 is equal to angle 2, angle 3 is equal to angle 4, and then BP is equal to CP. 1 is equal to 2, 3 is equal to 4, then BP is equal to CP. Now tell me, for angle 1 and angle 3, which is the included side? Online students, for angle 1 and angle 3, which is the included side?
Side AB, ma'am.
AB. And for angle 2 and angle 4, which is the included side?
Side CQ, ma'am.
CQ. Perfect, CQ. But we have not mentioned about those 2 sides, the included sides. Actually, for these 2 angles, angle 1 and angle 3, AB is the included side. For 2 and 4, CQ is included side, but we have not written that here. So it is some other side, 2 angles and some other side. So AAS. Again, you can also mention like this. You can write angle 1 is equal to angle 2 and angle 5 is equal to angle 6, vertically opposite angles, and BP is equal to CP. 1 is equal to 2 alternate angles, 5 is equal to 6 vertically opposite angles, and then BP is equal to CP. That's given. P is the midpoint of BC. Now tell me for angle 1, anybody online also? For angle 1 and angle 5, which is the included side here? A?
P, ma'am.
AP, ma'am.
AP. Yeah, very good. And for angle 2 and angle 6, which is the included side?
PQ, ma'am.
Side PQ, ma'am.
PQ. PQ. Have you written AP is equal to PQ here? Have you written AP is equal to PQ? AP is equal to PQ. Have you written that here? No. So it is not included. You have written 2 angles and some other side. If you list these 3 equalities, if you list these 3, are you following, all of you? If you list these 3 equalities, then in these 2 cases, it is AAS, 2 angles and some other side. Here I have listed 2 angles and the included side, because here we have mentioned, in this proof we have mentioned, you can see angle 1, angle 3. We have mentioned about angle 1 and angle 3 and BP, which is the included side. Then we have mentioned about angle 2 and angle 4, angle 2 and angle 4, and CP, which is the included side. So the rule is ASA. 1 minute, I need to correct that one. So the rule is ASA, correct? Yes or no? So the rule is ASA. Okay. So CPCT, we need to prove that AB is equal to CQ. AB is equal to CQ. AB is equal to CQ. QC, CQ, both are the same. QC, CQ, both are the same. CPCT. All right. Then we have to also prove that this one. Okay. Now, what is DQ actually? 1 second, Anirudh. What is DQ actually? What is actually DQ? DQ is DC plus CQ. That's what it is actually. It's actually, what is DQ actually? DQ is DC plus CQ. DQ is DC plus CQ. But we have proved that CQ is equal to AB. We have just proved that. So instead of CQ, write AB in the next step. DC plus AB. Because we have proved that CQ is equal to AB. So instead of CQ, write AB. Hence, we have proved that DQ is equal to DC plus AB. This one you don't have to prove. That is true already. This full thing dq is dc plus cq. That you don't have to prove because that is true. Instead of CQ, write AB because DQ is equal to, I'm sorry, CQ is equal to AB. So instead of CQ, write AB and that's the result. Just a minute, children.
But at the same time, these books, when we visit the stores, they don't really without making any sign, without making any mistake in the signs. I really understand how this would be very good. Or we can do, they have to take care. But you can do the best one.
Yeah, Chadu. So see how we present the answer in triangle. See, in this mention the two triangles ABP and CQP. Here you can name it in any order, children. Here you can name it in any order. You can call it ABP, A. One second, one second. One minute. Okay. Oh, you cannot write. No? Just a minute, children. I'm just having some issue with the projector. Just a minute. Yeah. Yes, children. So we have to take up this triangle and this triangle. So how do you start? In triangle AB, name the triangles. I said you can write the name in any order. So in this triangle and in this triangle. Okay, so you're going to say that angle 1 is equal to 2, alternate angles are equal, right? So mention the parallel lines. AB is parallel to CQ, AB is parallel to CQ, and BC is the transversal. AB, See, this is a transversal CQ. Parallel line, transversal, parallel line. See, this is parallel means here also it's parallel. Parallel line, transversal, parallel line. AB is parallel to CQ and BC is the transversal. Angle 1 is equal to angle 2. Alternate angles are equal. Then BP is equal to CP because P is the midpoint. And then angle 3 is equal to angle 4. Vertically opposite angles are equal. For vertically opposite angles, you don't have to mention parallel lines. Vertically opposite angles, you don't have to mention parallel lines. Yeah, and then the two triangles are congruent by the ASA rule. ASA congruence criterion or ASA congruence rule. And then AB. AB is equal to QC or CQ, CPCT. Then I told you this one. The next one I told you. DQ is equal to DC plus CQ. Then in the next step, instead of CQ, write AB because we have proved that CQ is equal to AB. CQ is equal to AB. Next step. So simple. I think we finished writing this one. No? Finish or no? Aragamai? Niveda? Huh? You still write? Not completed, huh? Okay. Finish it. Online children, finish writing this one?
Yes, ma'am.
Okay. All right. So in the given figure, OA is equal to OB. OA, where is OA? OA is equal to OB, is equal to OB. Okay, OA is equal to OB. All right. OP is equal to OQ. OP. Oh. OP is equal to OQ. So from this, you can understand that PA is equal to BQ. Because, see here, children. See here, it's given that OB is equal to OA. All right. Then a part of these two line segments, OP is equal to OQ. That means the remaining portions, PA should be equal to BQ, right? Okay, let's now the question is how and why. Let's see that. Now, supposing the whole thing is 10 centimeters. Then here also, because they're equal, this whole thing is 10 centimeters. Now, supposing this is 7, this one is 7, OP is 7. So then OQ is also 7 because OP is equal to OQ is given. Then how much is the remaining thing OB? 10 minus 7, 3. Here, how much is the remaining thing AP? 10 minus 7, 3. So 3, 3, you can see PA is equal to QB. So to present it, you can write like this. OA is equal to OB. All right, then OQ. No, you should write OP because in OA we have OP, right? So OP is equal to OQ. Now you can subtract these two. What is OA minus OP? OA minus OP is AP is equal to what is OB minus OQ? PQ. Like this, you can get the new result. AP is equal to PQ. See, you will say, no, you've written it in a different way. You can write it like this also. Okay. See here. So you can present it in one line like this also. What I've written here, OA is equal to this OA. Okay, let me change it, children. Now that I explained this, let me change it. You can show these steps. Here you can show these steps. What is it? You can just put a bracket in your book. Don't strike it. You can put a bracket and write these steps. So you write OA is equal to OB. Then in OA you have OP. So OP is equal to OQ. And when you subtract these two, you get OA minus OP. OA minus OP is how much? AP is equal to OB minus OQ, which is BQ. Subtracting. Subtracting, we get it. Right, children? Okay, I haven't started explaining the proof actually. I was only reading the question for you, right? So as I was reading, I just made that correction. Yeah, we haven't come there actually. We were just reading the information given. I was telling you that when you have this information and this information given, you can also get this information is what I was trying to say. You can also find that these two sides are equal. These two line segments are equal. That's what I was telling you. Now, prove that Px is equal to Qx. See, you need to focus a lot, children. Correct? I cannot get into your minds and see if you're really focused. My God, so difficult. If we have to take a photograph, and I ask you all to smile, I think only Krishna Priyan and I'll smile. All the others would be like. Okay. All right, children. So Px, we need to prove that Px is equal to Qx, right? Px, where is Px? This one, Px is equal to Qx, is equal to Qx. Okay. Yeah. Where is Px? This one is Px is equal to Qx, Qx. Now, sometimes what happens is, you will find that these two line segments are in more than one triangle. Like you will say that for Px, you will find that for these two line segments to show that Px is equal to Qx, you will see that there's more than one triangle which you can take up. But you should take up those two triangles where you have sufficient information to prove that they are congruent. Simply taking two triangles. Okay, the triangles may have those sides, but if you don't have sufficient information, then again you cannot prove. Okay, so see here. In triangle OAQ, where is OAQ? OAQ. In this triangle OAQ, in triangle OAQ and OBQ, this one. Yeah, which are the equalities here? OQ is equal to OP, that's given, right? OQ of this triangle, OQ of this triangle, OQ of this triangle. But 1 minute, we have to prove what? Have we proved that Px is equal to Q? Yeah. Yeah. Now let me not go in this order. I'll tell you why we have 1 minute. Let me explain this first. Now Px is in this triangle, right, children? Px is in this triangle. And where is Qx? Qx is in this triangle, right? This triangle, right? You can see here Qx and Px. Now just take up these two triangles and see if you have information to show that they are congruent. Tell me. Because what have we understood? You should take up the triangles in which you have those sides. Px, where is Px? Here is Px and this is the triangle. And where is Qx? This is Qx and this is the triangle where we have Qx. Now what you have to say is, okay, let us take up these two triangles. Do you have information? Do you have three equalities? Do we have three equalities there? See, like we know vertically opposite angles. Angle 1 is equal to angle 2. Yes, we know. Correct. And then we also, you remember, we subtracted, we said AP is equal to BQ. AP is equal to BQ, we said, right? Yeah, but we need one more. AX is equal to, louder darling, AX is equal to, that we have to prove. AX is equal to BX, we have to prove. Not given, it's not given. Prove that AX is equal to BX. Yeah. Is it given? Yeah, that's what. No, it's not given. You're saying X is the midpoint of BP, so BX is equal to PX. No, it's not given. We can't assume anything. For everything, you should give a reason. You cannot say it looks like that. No, it should be given. So to prove these results, in fact, to prove both these results, you need to take up these two triangles. To prove this result and this result, we have to take up this triangle and this triangle. Okay, because you have PX, QX here. PX is here, this triangle, and QX is here in this triangle. And then AX and BX, here AX is in this triangle. AX is in this triangle, and BX is the side of this triangle. So you need to actually take up these two triangles. Once you show that they are congruent, you can get both the results. Yes or no, children? You can get both these results. Then why don't we take up those two triangles? Because we don't have information. We only know that angle 1 is equal to angle 2, vertically opposite angles are equal. And then we also know that this BQ is equal to AP. BQ is equal to AP. Nothing else we know. Nothing else we know. Nothing else is given. So here we are trying to find an information. What you're doing here is we're trying to find an information. We want one more information. We are trying to find that information here. For that, we are using the triangle AOP and BOQ. So the answer is actually here. The answer is actually here. But when you take up these two triangles straight away, you can see that we don't have sufficient information. We can only write angle 1 is equal to angle 2, vertically opposite angles, and AP is equal to BQ. Other than this, we don't have any other information. No other. One more equality you need. We don't have. For that, to find that one more equality, we're doing this. We're doing this. So we take up this triangle, and this triangle, because we have these two things. OA, OP, which triangle? OA and OP. Where are these four line segments, children? Now, again, your question will be, how do I know that I have to take up those two triangles? You should take up the triangles based on the information given here. OA, OB, OP, OQ. OA, see, OA, OQ, OQ, OA and OA. Where's OA? This one is OA. And then OB. Where's OB? This one. This one. See, so we have information about these two line segments. So complete the triangles. You take up this triangle and take up this triangle. These two triangles. This one triangle and this one triangle. Now in these two triangles, OA of one triangle is equal to OB of the other triangle. In this triangle, it's OA. I'll draw the triangle separately for you here. I'll draw the triangle separately for you. Here. This is OAQ and this is OPB. Okay, I've taken the triangle separately. So you can now use this information. We have taken these two triangles because we can use these two information given. OA is equal to OB. OA is equal to OB. Then OP is equal to OQ. Where's OP? OP, this one, is equal to OQ. Now you understand why we have taken up these two triangles? Because another information in the triangles is useful. See, now we have marked. You can see the triangle separately now. Watch the triangle OQA, that bottom triangle, and this OPB. And I've marked that information. OA is equal to OB. And then OP is equal to OQ. Yeah. And then now for these two, now you can see that these two triangles have this one as a common angle. This angle is common to this triangle and to this triangle. This angle is common. See, this angle is in this triangle. It is also in this triangle. It is also the same angle is also in this triangle. This is the common angle. This angle is common to both the triangles. It's common. It's there in both the triangles. So this makes SAS. See, side, angle, side. Two sides and included angle. SAS rule the two triangles are congruent. SAS rule the two triangles are congruent. Now it's time. So from these two triangles, you can write that angle A is equal to angle B CPCT. We'll take up this sum again in the next, this proof again in the next class. Angle A is equal to angle B CPCT. So we have got this information. Angle A is equal to angle B. Angle A is equal to angle B CPCT. Now take up these two triangles. Angle 1 is equal to angle 2. And this angle which we just proved, angle 3 is equal to angle 4, say, which we just proved. And then this side is equal to this side. By subtracting, we got no. So it is two sides and some other angle. Sorry, two angles and some other side it is. It's two angles and some other side. These two angles and some other side. So AAS rule the triangle are congruent. CPCTC, you will get both the results. You will get both these results by CPCT. Okay. Since it's time, I'm just abruptly stopping. We'll actually discuss this again. If there was time, I would have done this again for you. We'll continue with this and from this on in the next class. All right. All right, online students, that's it for today's session. Thank you so much. Good night. You may leave the call. Thank you, children.
Thank you, miss.
Thank you. Good night.
Thank you.
Good night.